Okay guys, this is the mapping unit. Remember, you need to handwrite your notes or you need to take the notes in some sort of notes app, something along those lines. Make sure I can see them as soon as you come to the next class. The title is mapping. Okay, we're going to skip videos for now. There we go. Okay, a cartographer is a person who makes the map, and cartography is the science of map making. Without cartographers, who shockingly are very, very important, um, we wouldn't know that anything existed, and we'll get to more pictures and stuff later. Okay. Make sure you know that Earth, as viewed from looking down from Polaris, that's the North Star, the Earth appears to turn counterclockwise. This is why the sun rises in the east and sets in the west, in the northern hemisphere. Okay. Earth is not round. It's actually called an oblate spheroid. If you look at it, it's fatter in the middle than it is at the poles. That's what makes it an oblate spheroid. Okay, here we go. Lines of latitude are also called parallels. These are lines that run parallel to the equator. They're measured from 0 to 90 degrees north or south, depending on where you are. The equator, I should hope you know, it circles the Earth halfway between the poles, and it divides the Earth into the northern and southern hemispheres. The equator is 0 degrees. Geographic South Pole is 90 degrees south, and geographic North Pole is 90 degrees north. Lines of longitude are also called meridians. They run up and down the globe from pole to pole. They measure distances east and west of the prime meridian, and they measure meridians from 0 degrees to 180 degrees. The prime meridian is found at 0 degrees, and you need to know that it runs through the town of Greenwich, England. The international dateline is found at 180 degrees, directly opposite the prime meridian, and it serves as a transition for calendar dates. Okay, these right here are lines of latitude. They measure distances north and south of the equator. Right here are your longitude lines. Okay, they are long and skinny. They run from pole to pole, kind of like segments of an orange. They measure distances east and west of the prime meridian. Okay, we're skipping videos. Okay, we're doing this in class. Just go right by it. Don't even worry about it. Okay, the international dateline is located at 180 degrees, opposite the prime meridian. I've said that already. I have to take this out. Just ignore it. Okay, in your notes, answer these 4 questions. What do you think is the only line of latitude that is considered a great circle? Number 2, to find the exact location of a business, what information would I need? Number 3, what star can tell me the latitude in North America? And number 4, we need to just ignore number 4. I need to get rid of it. They took time zones out of your objectives. Okay, when you're looking at a globe, because we'll be using globes in class, okay, longitude is actually printed across the center. This blue line on your globes in class have numbers that go up and down on them, and those are lines of longitude. Latitude is on that gold bar. So each of these numbers correlates to a line of latitude. Okay, a map legend are the symbols that represent items on a map, just as you'll see over here, like an airport looks like a little plane, a hospital has an H, a cemetery has little crosses, roadways, you can tell what a roadway is. An interstate marker will look, like the ones that you see around here. Most roads tend to be a solid line. Okay, a map scale is a numerical distance assigned to a map. A verbal scale is where it tells you literally the measurements. 1 centimeter on the map is equivalent to 1 kilometer in real life. Sometimes you'll see these weird fractional units. All this means is that 1 unit on the map is equal to 63,500 units on Earth, but a lot of times it doesn't tell you what that unit is. What we end up using is the verbal scale. Topographic maps show relief of Earth's surface. All the relief is a change in elevation. It's sort of the lumps and the bumps, the high spots and the low spots. It can be a mountain, a river, a forest. It can be a valley. Okay. Topographic maps have contour lines on them, or sometimes you'll just see a contour map. Okay. A contour line connects areas of equal elevation. The lines never cross. When they're close together, it means that there's a really steep slope, and when they're far apart, it means there's a gentle slope. Contour interval is showing these two lines that are directly next to each other. The contour interval is just the difference in elevation between two side-by-side lines. And the contour index is the distance between two marked lines. Like this one is 600 and this one is 500. So the difference between 500 and 600 is 100. So the contour index is 100. Depression contour lines have these little hatchers that go on the inside. See these little lines that come in? They're pointing to the ground that's lower than the surrounding area. So a crater would have hatcher lines. The entrance to a mine might have hatcher lines. Rivers and streams, you can always tell where those are because, do you see what my green lines are doing here? The contour lines bend upward towards the source of the river. So the contour lines bend up as the water rushes down. Ignore, ignore, ignore that. Okay, and finish these 3 questions and you are done with your notes. So how do you tell the difference between a depression and a mountaintop when you're looking at a topographic map? Think about what a depression has that other contour lines wouldn't. Explain the difference between contour interval and contour index. And how do you determine the direction in which a river flows when you are looking at a topographic map? I expect to see the answers to your questions embedded within your notes, and see you next class.